Question 12. Consider two identical galvanometer and two identical resistors with resistor R. If the internal resistance of the galvanometers RC is less than R by 2, we have to check the correct statement about the galvanometer. First, the maximum voltage range is obtained when all the components are connected in series. The maximum voltage range is obtained when the two resistors and one galvanometer are connected in series, and the second galvanometer is connected in parallel to the first galvanometer. Option C. The maximum current range is obtained when all the components are connected in parallel. Option D. The maximum current range is obtained when two galvanometers are connected in series and the combination is connected in parallel with both the resistors. In this question, we know that let the maximum current allowed for which resistance should be minimum. So let the maximum current allowed through the galvanometer be Ig. Now in the first case, that is a series connection, so we can say resistance 1, resistance, and resistance. So we can say this is my RC, and it is R, and it is R. So we can say the potential difference between these Vs is equal to current flowing through them, that is equal to 2 RC, so it would be Ig into 2 RC plus twice of R. So this would be the value of potential. Now if we made this a parallel connection like this, RC and RC are connected in parallel and they are in a series with this connection, RC and RC again, and this is point Vp. So we are going to calculate potential difference at these 2 points. Vp is equal to Ig into RC. So it should be RC by Ig current flowing through this, Ig into RC plus the value, because RC by 2 and the resistance in series, that is equal to 2R. So finally we got a relation from this. Vp is equal to Ig into RC plus 4R by 2. Now we are going to calculate their ratios. How much we got it? That is Vp upon Vs is equal to RC plus 4R by 2 into R plus R into C, that is also 2 from this part. 2 into 2, that should be equal to 4. So we got Vp upon Vs, that should be equal to RC plus R plus thrice of R upon 2 into R plus RC. So we got that Vp upon Vs, it is equal to 1 by 2 plus 3 by 2 R upon R plus RC. So we will check the condition for resistance galvanometer. If RC is less than R by 2, this is given. So we can say R plus RC is less than 3R by 2 if we add R both sides. So we got 1 upon R plus RC should be greater than 2 upon 3 into R. What we got from this relation? So from this relation we got that which option is correct at this side. So from this option, if we check 1 upon RC of this relation is correct with that choice. So for this part we can say option when the maximum current range is followed by this relation. So we got maximum voltage range is obtained. Maximum voltage range is obtained. So option B should be correct, in which when they are connected in parallel with the first galvanometer. So we satisfied the condition for this statement. Second, we know that maximum current range is obtained when all the components are connected in series. So we specially choose, because we need to draw the circuit for every statement and then find out the condition, find out the ratio of potential, and then we found that it is correct for option B and option for this part because maximum voltage range obtained when they are connected in series. This is option B is absolutely correct. With this we are going that when the maximum current is flowing, option A. So we can say option A and option B both are the correct choice in this question. Question 13. In question 13 we are given in a circuit shown below keys are pressed at t equal to 0, which of the following statement is correct? Now when the key is pressed at t equal to 0, the voltmeter displays minus 5 volt as soon as the key is pressed. So we know that when the key is pressed, the arrangement would be look like this. It will be short circuit, and current would not like to flow through the load circuit, like resistance would be neglected over here, and then it would be like this. So we are going to consider the potential difference at point this A and B, and this comes to be how much? That is equal to minus of 5 volt. Now when the key is pressed, we need to calculate the potential across this. So when t is after a long time, so we can say when t tends to be infinity, the circuit will behave as it is open, because we know that when at a long time capacitor is full charge, it will behave as open circuit. So there would be a resistance connected this side, and there would be a circuit over here, and there would be resistance connected this side. So we know that there are two resistance connected in series. So we want to know the potential difference between these 2 points. So this is negative minus positive over this. So it would be equal to, we know that this is point B having potential 0 volt, and this is equal to 5 volt at point C. So we are going to calculate this is VC minus VV is equal to positive 5 volt, as option A is the correct choice. Now we will choose for this part. The voltmeter will display 0 volt at time t equal to log t. So at time t equal to log t, we are knowing that circuit will behave. This is, yes, so it should be for the first part. For first part means I'm talking about this one. For the second, this is. So at time t equal to log 2, we can say 40 microfarad, and this is 25 kilo ohm, and this is at potential positive 5 volt, this is at 0 volt. So we know that growth of current as a function of time t is equal to net maximum of V by its resistance R max, that is equal to 25 kilo ohm into e to the power t upon RC. RC is the time constant, so we can say that is minus t upon tau 1. Substituting the values of this tau 1, that is equal to R into C, so it comes to be 25 into 10 to the power 3 into 40 into 10 to the power minus 6 second. So from this relation we got tau 1 is equal to 1 second, and also we are given t is equal to log of 2, this value. So on placing the value, we got at it is this, so we got VV over this is at time t equal to log 2 ln2, it should be equal to 5 volt upon e to the power log of 2, so that should be equal to 2.5 volt. Now voltmeter reads, so we know that voltmeter reads 0 volt when t is equal to log 2 second, and this is also the correct choice, option B. I am going to consider option 3. Now with that, because voltmeter 0, how it can read? Because if the potential at this point we want to know, and potential at this point are same, so we can say voltmeter will read 0. So what we need to do, we need to calculate current flowing in this circuit as IT1 and current flowing in this circuit as I22, and we know that we will calculate if the potential at these 2 points VV and VC are equal, so we can say this will be equal to 0. So similarly we are going to calculate current growth as this. So as there is a 50 kilo ohm like this, and also another capacitance connected in series that is equal to 20 microfarad, and this is 0 volt, and this is again positive 5 volt. So we are going to calculate the value of current I2 is equal to maximum voltage divided by its value 50 into 10 to the power 3 into e to the power minus t upon the tau 2. So tau 2 is just the time constant, that is equal to R2 into C2. So from this we got, that is again 1 second. So we got the value of Vd. Vd is equal to how much? That is Vd at a function of at time t equal to log t. So it should be equal to 5v minus 5v upon e to the power log 2. So we got 2.5 volt. We are going to calculate potential difference at point BV and VD. So we got VV is equivalent to VD, that is equal to 25 volt. So we know there would not any current flow through this. So we can say this is also the correct choice. Now initial value of current through the voltmeter. Option C, we note initial value of the current at time t equal to 0, I2 across the ammeter is this. So from this curve we also got that option A is correct. We proved it. Option B is correct. The current in the ammeter becomes 1 by E times of the initial value after 1 second. So we know that this time we will calculate the value of current initially, I10 plus I20. Okay, now after 1 second, current through the ammeter, current through the ammeter is I1 as a function of 1 second plus I2 as a function of 1 second again should be equal to how much? I1 into e to the power minus t upon that, and we put the values, that is I1 as a function of 0 upon e plus I2 as a function of 0, because we know that whenever there is a discharging, I is as a charging, I equal to I naught e to the power minus t upon r into c. Already we calculated the value of RC as equal to 1, and now time t. So we are given t is equal to 1 by e, so that is cancelled out. Finally we got it equal to e. So solving this resolution, we also got option C is the correct choice. Now we will check option D. Option D will also the correct choice in this part. That can be proved from relation C and relation D. So we got all the options are correct. Option A, option B, option C, option D. This was a moderate question based on transient current effect, in which a DC battery is connected across a bridge based capacitance and resistance circuit. So in the first statement we calculated the means it is given at time t equal to 0. So we know that at initially capacitor will behave as a short circuit. After a long time capacitor will behave as an open circuit. Case 2, we would like to calculate potential difference across the voltmeter connected. It's better to know potential at the junction point. Potential is equal to current into resistance R. So current should be calculated. So we know that growth of current as a function of time t is always IT is equal to I naught e to the power minus t upon R into C. We put the values and got the answer. That's why option A is correct. Option B. Now option C, the current in the ammeter becomes 1 by E times of initial value. So we know that initially current was, first of all we will calculate the initial current at time t equal to 0 when the circuit was open circuit. Fine. After a certain time t, the charging of capacitance take place. So we would calculate the current as a function of time t as 1 second. So we got that is a function of 1 by E. And option D, the current in the ammeter becomes 0 after a long time. So when t equal to infinity, current will become 0 because it will behave as an open circuit. That's why we got all the options correct. Question 14. A block with mass capital M is connected by a massless spring with stiffness constant K to a rigid wall and moves without friction on a horizontal surface. The block oscillates with small amplitude A about an equilibrium position x0. Consider two cases. Case 1 when the block is at x is equal to x0. Case 2 when the block is at x is equal to x0 plus a. There is some extension of amplitude. In both the cases, a particle with mass m is less than capital M is softly placed on the block, after which they stick to each other. Which of the following statement is true about the motion after the m is placed on the mass capital M? So we have to check the correctness of all the options. As first option is the amplitude of the oscillation in the first case changes by a factor of capital M by m plus m, whereas in the second case it remains unchanged. Option B, the final time period of oscillation in both the cases is same. Option C, the total energy decreases in both the cases, and option D, the instantaneous speed at x0 of the combined masses decreases in both the cases. So we know that first of all in case 1 we know that speed of mass m, that is equal to a into omega naught. We know that omega naught is the natural frequency that should be equal to stiffness divided by its mass m. Now after the block m is placed, so we got speed of the combination will become is equal to small m upon capital M plus small m multiply by a into omega naught. How we calculated these values? So that is what a into omega. So omega will be changed from this part. Now we are going to calculate, that is frequency of the first and second can be calculated. So means because tangential velocity of vt1 and vt1 that will be same, so it should be equal to capital M into a. So capital M into a into omega naught. So omega naught into this value, so that is equal to under root of small m upon capital M plus m into a. That should be equal to new amplitude, because we are given that tangential velocity v as a function of time t, and also we know that its new time period frequency will be equal to k upon m plus m. From this relation we would like to calculate the amplitude of new system, that is equal to a dash is equal to under root of small m plus capital M into a. In this concept simply we need to calculate the tangential velocity, or we can say velocity of the particle when the block was isolated, and later on we put an object of mass m, so its frequency changes. So frequency changes is equal to under root k by capital M plus m, and now we got the same answer, vt1 equal to vt2. So we put the equal, you got new amplitude, a dash is equal to under root of small m upon capital M plus m into a. Second part, final time period of the oscillation in both the cases same. Okay, so final time period will be same, of course it is correct. Now option 3, total energy decreases in both the cases. Not, total energy will remain same as no external force is acting, so we can say total energy of the system will remain same, that is remain same. Option D, the instantaneous speed is decreased clearly at x0 in both cases. So of course the instantaneous speed at x0, that is dx upon dt, is equal to v, and that is equal to a into omega. As frequency is changing, definitely this value will change. As option A, we can say option A, B, C is wrong, option D. So we can say option B, A, B, D are correct. This was a moderate question asked. Now in this part, question 16, it was given as a frame of reference that is accelerated with respect to inertial frame of reference. Means a frame of reference that is accelerated with respect to an inertial frame of reference is called a non-inertial frame of reference. Now a coordinate system fixed on a circular disk rotating about an axis. So this is what a disk is meant, and also it is connected with a disk like this, and it is the axis of rotation of this, which is rotating with angular velocity omega. There is also a groove over this side in which a block is placed. Now a coordinate system fixed on circular disk rotating about a fixed axis with a constant angular velocity omega is an example. Okay, omega, the relationship between the force F rotational experienced by a particle of mass m. So it is at a distance r by 2, and the radius of the arrangement is r, and its mass is given as m. Now we are given F rotational. Is equal to Fm. Yeah, question was like that. Question 15. We can read the question. A frame of reference that is accelerated with respect to inertial frame of reference is called a non-inertial frame of reference. A coordinate system fixed on circular disk rotating about a fixed axis with a constant angular velocity omega is an example of non-inertial frame of reference. Now the relationship between F rotational experienced by a particle of mass m moving on a rotating disk and the force F m experienced by the particle is F rotational is equal to F in plus 2m v rotational into omega plus m into omega cross r equal to omega. If v rotational is the velocity of particle in a rotating frame of reference and r is the position vector of the particle with respect to center of the disk. Now consider a smooth slot along the diameter of a disk of radius r rotating counterclockwise with a constant angular velocity omega about its vertical axis through its center. We assign a coordinate system with the origin at the center of the disk, the x-axis along the slot, the y-axis perpendicular to the slot, and the z-axis along the rotation axis, that is omega equal to omega k. A small block of mass m is generally placed in the slot at radius r equal to r by 2. So we have to find out the distance of r of the block at time t. So in this question we need to solve that how we got this solution. Okay, so in this question we are given that a mass is placed gently in a slot and the radius of the slot was given as capital R when it was rotating with angular velocity omega. So we have to find out its value. So distance of R about as a function of time t. So we know that in this question, that is its acceleration is just like a tangential acceleration. So we can say it experiences a centripetal force Fc, that is equal to translatory force. So we can say that is equal to m into r omega square equal to m into a. So we got a equal to r of omega square, and we know that acceleration is equal to how much? That is v into dv by dr. R is a position, that should be equal to r omega square, and where v into dv is given as r into omega square into dr. So we are on integrating this relation, finally we got the relation as v equal to, because we need to put the limit, velocity is from 0 to v and this is from r by 2 to capital R. R by 2 to capital R. So, or we can say we can take this limit from R to capital R from this, or 0 to capital R. Okay, because the function will remain same, 0 to value of because small r, or it should be small r by r to r by 2. Now we got that from this relation, that is equal to v equal to omega under root of r square minus capital R square by 4, and now that is equal to its velocity. So on calculating this velocity terms, we get finally as that limit is taken from r by 2 to r into dr upon under root of r square minus r square by 4, that should be equal to omega into dt. Limit is taken from 0 to t. Solving this relation, finally we will keep in hold this one. Now from the graph, from the diagram we are given, we will calculate that r is equal to r by 2 into sec of theta. On differentiating this, because we are given dr, so dr is equal to r by 2 into sec theta into tan theta into d theta. So on taking this value, that is equal to 0 to r by 2. Okay, or we're placing the values to dr, that is r by 2 into sec theta into tan theta into d theta upon under root of r square by 4 into tan square theta, that should be equal to omega dt. Limit is from 0 to t. Now from this part we got omega t is equal to n into 2r upon capital R plus under root of 4r square minus r square by r. So from this part we got the time t. So time t finally come as a function of t equal to r by 4 into e to the power omega t minus e to the power minus of omega t, and that match with the option in from the figure, that is r by 4, option D over here. So what we did in this question, we know that when the mass is in translatory motion but it was fixed on this globe, so its translatory force is m into a, and it experiences a fictitious force that is due to centripetal force. So ma is equal to mr omega square. So we would like to calculate the value of v at that position r, v as a function of at that position r. Now we know that there is angular displacement occurred over this side, so we calculated the relationship between capital R and a small r, and we got r is equal to r by 2 sec of theta. So we differentiate it, we put it into the main relation, get the function of omega, and just solve the equation for t. So on the basis of this relation we got option D. This was a difficult question asked in JEE Advanced. Now question 16. In this 16 question, they ask the net reaction of the disk on the block is. So net reaction of the disk on the block is, so we have to calculate net reaction of the disk. So net reaction, as it is rotating motion about fixed axis of rotation, so we know that from the equations we are given, net reaction, so as it experiences a force radially outward, so we can assume this is I cap, and you can assume this as Z cap, y axis. This is y axis, this is x axis. Now we know that in the relation we are given F rotational is equal to F in plus twice of m into V I plus omega k cap into rj cap cross omega k cap. We need to mention the direction of angular velocity position vector r from the statement given in the previous question, that is. So we know that this force should be equal to mr omega square along I cap. We can see here that is centripetal force should be equal to Fi in vector plus twice of m into V into r rotational omega along minus j plus m v's omega square into r I cap. From this relation we get the value of Fi in, that should be equal to Fi in plus 2mb. Fi in, that should be equal to twice of m into v r omega g cap, because yeah, now we calculated the value of a small r as equal to r by capital 4 e to the power omega t plus e to the power minus of omega t. So we know that from this relation already we calculated, but this time we want to calculate the normal reaction, and what should be the value for this part. So normal reaction Fm should be equal to, placing the values of these general terms, normal reaction, that is F, is equal to twice of m into r omega by 4 into e to the power minus omega t plus e to the power minus of omega t into omega g cap. And we got Fin is equal to m into r omega square by 2 into e to the power omega t plus e to the power minus of omega t. Okay, so from this part we calculated all this relation, and we got F reaction is equal to m into r omega square by 2, the relations of their angular velocity, and that is equal to mg into k cap. And hence we got option, from the upper relation we got option D as a correct choice. Option C, option, there should be a plus sign over here, e minus omega t plus mgk, it is plus mgk, it is omega square into r 2. Yeah, option C is the correct choice. As we calculated our radius, we calculate our radius as a function, that is r by 4 into e to the power minus omega t plus omega t minus e to the power minus omega t from this relation. So this was a moderate question in which we calculated the normal reaction when the object was restricted to move in that group, and it was due to pseudo concept, that was centripetal force. Hence option C was correct question. Question 18. In this question 18, we are given, consider an evacuated cylindrical chamber of height h having rigid conducting plates of ends and insulating curved surface shown in the figure. Now we know that in this question we have to find which of the following statement is correct. The walls were found linked to the bottom plates carrying the opposite charge they went up with. Option B, the walls will execute simple harmonic motion between them. So we have to find the solution of this question on the basis of graph data given over here. In this question, as we need to read the question again. Consider an evacuated cylindrical chamber of height h having a rigid conducting plates at the ends of an insulating curved surface as shown in the figure. A number of spherical balls made of lightweight and soft materials are coated with conductive material are placed on the bottom plates. The walls have a radius r which is less than h. Now a high voltage source HV is connected across the conductor plates in such that the bottom plates of the arrangement, bottom plates is at potential positive E and the top plates is at potential minus of V naught. So due to their conducting surfaces, the balls will get charged, will become an equipotential with the plates are at repelled by it. Now the balls will eventually collide with the top plate, where the coefficient of restitution can be taken to be 0 due to the soft nature of the material of the walls. Now the electric field in the chamber can be considered to be thin to be parallel plate capacitor connected across this. So we are given a battery connected over here. Now there is a cylindrical chamber we are given having a potential difference. Ammeter is connected in series with that. So we have to find out the correct statement over here, as we are given the 4 option. So we know that in this part yes, balls will back bounce. So means when there is a potential difference, electrons will enter this side, protons will enter this side. So we know that they will ionize and the repulsion will take place. That's why these positive charges would like to means positive charge would like to move towards the electron, and this negative charge would like to move towards this. Hence the balls will bounce back to the bottom plate carrying the opposite charge they went up with there. So means option A is the correct choice. So they will go in opposite direction. That's why option A is the correct choice. This was a moderate question. Now we are going to calculate the average current in the steady state registered by the ammeter in the circuit will be. So in this, from this part we need to calculate the average current in the steady state registered by the ammeter. So we know that in this situations that whenever there is a potential difference like this, so it is at minus V naught and this is at positive V naught. Now there is electric field also upward, and positive charge will follow the direction of electric field. So this is equal to 2V naught by this, by the separation between them. It is given by Hy2. Now just before the collision and just after the collision, so we know that as the charge is moving over here, it is direction will be changed when it collide with that. So we know that from this part the potential of electrostatic interaction, that is KQ by R, should be equal to V, should be equal to Q, that should be equal to V naught upon the dielectric constant of the material we are given over here. Now we can also know that the height that is 1 by 2 AT square, acceleration is equal to 1 by 2 force of electrostatic, that is QE by M into T square. Now from this part we know that placing the value of electric field, that is equal to 1 by 2 potential into that separation K, and that is equal to that into 2V naught upon M into T square, that is equal to H. Finally from this part we got the value of time T. It means we will use the normal relation, and finally we will get average current T, average current, that is I, equal to net charge dq upon T, time taken, that should be equal to 2V naught square upon H into R root R upon M K root K. So this is directly proportional to the square of the velocity. Hence option B should be the correct choice. So we are given in this question both the plates are at potential difference, electric field is there vertically upward, charge will follow the direction of electric field. So we will calculate the potential difference in that particular medium. So that is KQ by epsilon into KQ by R, and we also get the height and time H is equal to 1 by 2 AT square. From these relationship we will get the value of R average current, which is directly proportional to V naught square. So this was also a difficult question. So in this paper there were 18 questions on physics, which was considered to be difficult as compared to last year and last year papers. So we can say this paper was 30% difficult and 45%, we can say 45 to 50% this was moderate. Only 2 or 3 questions were easy. Thank you.